Hey everybody. Okay, so we're going to continue working with our three-dimensional solids, and today we're going to be talking about the surface area and how to find the surface area and how to calculate it. And hopefully you guys were had some practice being able to draw your nets, because those are very helpful, certainly helpful to show students what we're doing. It's possible, you might get good at this. You don't need to draw the net in order to find the surface area, but when you're trying to teach someone else, it's really helpful to be able to draw those nets so that you can show them the different shapes, because a lot of kids can't visualize what shapes we're talking about. So what we're going to do here first is we're going to just talk about what the dimensions of the different shapes are. Some of this is going to be pretty easy. It's going to be pretty straightforward. Others are a little bit trickier to see, perhaps, so we'll take a little bit more time at it. Once again, this is a much better activity if we were live, because a lot of the demonstration stuff that I'm going to be doing with you guys, I would have had you guys actually doing, building, and cutting out. But because of the situation we're in, I'm going to try and give you the experience as best I can, as if we were all here together and you were actually doing this. So if you want to try and pause it and build along with me, it might be helpful, but I'm not going to require that of anybody. Okay, so here we go. We've got prisms on the top and then pyramids on the bottom. So we're going to talk about them because the dimensions of these are very different. So we'll just talk about them. I'll tell you right now, prisms are quite a bit simpler. So when we're talking about prisms, you're going to usually be given your dimensions, basically telling you for rectangular prisms, they tell you length times width times depth. There's a lot. It's 3, right? It's usually going to be 3 of them because there's going to be 3 different dimensions. So when I look at this, if this is my my prism, let's say I'm laying it down like that, kind of looks closer. This is a square on the bottom, and what I drew is clearly not a square, but it's more or less the same shape, right? So if I'm talking about dimensions, what I have here is I have a length from here to here, which we would call the base, and a length from here to here, which we would call the height. And then I have a length from the back base to the front base, or from the bottom to the top. And that's my third dimension. So for prisms, basically what you think about is you're given the base and the height of this bottom of your base, and then you're given how far apart the two bases are, and we call that the depth. If you look at how I'm holding right now, this would look like it's going deep into the paper, or deep that way. So we call that the depth. So a lot of times you have base, height, and depth. It'll actually be a D in the way they write it. So it could be width, height, and depth. It could be length, width, and depth. It could be length, width, and height. Basically, the names of them aren't real important. What is important is that you're given 3 of them. So for the one that I'm holding, it might actually be the same number. Maybe it's 5 and 5 because this is a square. But if this is not a square, if this is not a square, then you'll have a dimension for here and a dimension for here and a dimension for here. So I'm going to go ahead and color code a little bit, and we're going to assume that this is not a square. Yikes, slippery sucker. Okay, so here we go. I've done some color coding on this thing. So there is my red would be my base, my green would be my height, and that darker purple side there would be my depth, okay? So if I'm looking at this thing, this is my depth right here, okay? This is that red base right here. That one. And then this over here would be that height. It doesn't matter. I could have done that one or that one. Doesn't really matter. All right, so that kind of shows you the dimensions of it. So like I said, the the prism's not too bad. It kind of makes sense because we only have 3 of them. The pyramid is much different and much trickier to understand because it has different dimensions. So we're going to move on to the pyramid here. So if we look at the pyramid, okay, so we have a rectangle on the bottom, And again, I can do this just like I did before. So I've got the base here is something, right? Whatever that distance is. So there's my base. And then we got this part, which would be the, what would be, might call the height of the base. Okay. And then is the tricky part, right? So far, when we have done these color coding here, I've drawn my color on an edge. So you see it's like the edge here and the edge there. And if I go back and look at this one, the red is on an edge, the green is on an edge, and the purple is on an edge. So a very common mistake that students make when you're doing this with pyramids is they kind of go, oh, you know what? It's all the edges. So they go this edge, and then they're going to say that edge right there, from there to there. That is not a dimension of this shape at all. We don't use this. For any of our area, our surface area calculations or our volume calculations, do we ever use this side right here? Okay, so that's a very common mistake that students make, because they think, oh, it's edge, edge, therefore edge. That's not correct, all right? So what I'm gonna do with this one is I'm going to draw the net for it, and then we'll come back to the 3D shape. So if I got, this is my base here, and this is my height, okay? So now I'm gonna go ahead and draw this over here. So I'm gonna have two of those. They're both green, because that's that side and that side. Again, we're assuming that these are not a square, right? So a rectangular base, but not a square. Okay, and that one is that hot side, and then that side in the back. And then coming off of this is the height, or excuse me, is the triangle. Okay, so it's a triangle like that. And then these two would be the same, like that. And then if it happens to be a square base, then all of these would be the exact same length. But since we're purposely saying that we don't know if it is a square base, I'm gonna make the two blue, dark blue ones a little bit different than the light blue ones. Now what is true is those two triangles are the same, and those two triangles are the same. If that's an actual square base, then all four of these will be the same, okay? Okay, so if I'm gonna find the surface area of this, so find the surface area of this rectangle in the middle is pretty easy. It's base times height, no big deal, that's easy. How do I find the area of these triangles? Well, for this triangle, obviously I would need to know this base and then the height of that triangle. So I'd also need to know this distance from here to here. Okay, so I've got this base, yes, and then that height. Now, if I'm trying to find the area of this triangle, since it's a different size triangle, I have this base and I need to know this height. And then for area of triangles, we're going to use 1/2 base times height. So the formula is going to be a little bit different, but then it's also the height. Okay, so now notice where that line is, the dashed line. The dashed line is not over here on the edge. The dashed line is right square in the middle. So if I come back here and I go, okay, so there's my red. I can see this. So here's my red side, and there's my green side. And then, well, I guess I could do it like that. Okay, so there's my red side, there's my green side. Now, if I'm looking at this dashed line, where is that dashed line located? Well, you can see there's my green line, that's my green line, and that dashed line is going straight from the tip, straight down to the side. It's not one of these edges. That's what I was saying at the beginning. The height that I need for this triangle has nothing to do with this side over here, which is that side right there, and has nothing to do with this side over here, which is that side right there. Okay, so this height from the tip to the edge where that green side is has a name. So I'm going to draw that in there for us. Okay. So this dashed line is the same as that dashed line. And that dashed line has nothing to do with the distance from here to here. The distance from here to here is going to be longer than that dashed line is. So we don't want to use that distance if they happen to give it to us. So let's talk about that. What are we going to call that? Well, we'd like to say it's the height, right? But it's the height of what? Is it the height of the pyramid? Is it the height of the triangles? Because those are going to be different. So, what's the height of? So we call this distance. If you look at this, if I set it down there, and you can kind of see that this side is not going straight up, right? The side of this pyramid has a little bit of a, what would you call that? Has a little bit of a slant. And that's what that height is called. So the height from the base of your triangle to the point, the vertex of your pyramid, so right from the bottom straight to the top there, right in the middle, that is called the slant height of that pyramid. And slant height is what I use for the surface area. So if these are longer, that's going to have a different slant height because the triangles need to be longer. So it doesn't have to be the same. Now, again, if this is a square, then all of the slant heights would be the exact same. And of course, the 4 triangles would be the same. But no matter what, when you're doing surface area, you have to have the slant height. So I'm going to write that right here. That this is called the slant height. Okay, and we're gonna take a look at what other type of heights are here. Okay, so that's the slant height. So what I have over here is the net of a pyramid. Okay, so there's the net of a pyramid, and it looks pretty similar to that one. Looks like it might be a square, and this one actually is a square. And if that's a square, then what's that mean about these 4 triangles? Well, it means those 4 triangles are all going to be congruent because they're going to have the same base. And then if they're going to come up and touch in the middle here, then they would need to have the same slant, the same length from the base of this triangle to the top would need to be the same from all 4 sides so that it could meet. So we call that, of course, the slant height. So the slant height for this is from, oops, this is a good triangle here. I didn't mess this one up. Okay, so that's the slant height right there. Okay, so now here I have another triangle, and I put it on there, and you see that the pink triangle that I just cut is exactly, or as close as I can make it, exactly the same size as the yellow one. As close as I could do it, actually. Actually, that's pretty good. Okay, so it's the same size as the yellow one here, maybe. Yeah, there we go. Okay, so it's the same exact size, all right? So these 2 triangles, this one, this yellow one, and this pink one, are the exact same size. So what I'm going to do is I'm going to take this triangle and I'm going to put it on the inside of the triangle, of the pyramid. And then I'm going to close the pyramid up. And tell me what you notice when you look at this pyramid. What do you notice about this? It's kind of hard for me to keep it on the screen. This is where it's way better for you guys to be building this on your own. So I'm not trying to demo it out in no man's land. All right, there we go. Okay, that's good right there. So there you go, right? So here's my pyramid. What do you notice about the pink? The pink is what compared to the height of my original pyramid? Well, the pink looks like it is taller. I'm going to push it down. Nope, that's all the way down. The pink is quite a bit taller than the height of the pyramid. Yet, this pink piece is exactly the same size as that triangle. So why or how in the heck is this triangle, which is the same size, and that's the slant height on it, but when I tilt it, it ends up being lower than my the height of my pyramid. If I can do it this way, this might be good too. So I'll hold it like this. Okay, so I hold in the middle, and then when I push this over, you can see that the There we go. You can see that the triangle, the pink triangle, is quite a bit taller than the yellow triangle is. If I close them all the way in, that's still the case. So what that means is that the slant height is not the same as the actual height of my pyramid. The slant height is going to be a little bit longer than the height from my finger to my thumb. Whoops, from my finger to my thumb. So the slant height is a little bit longer than the height from my finger to my thumb. So that's why we have to be careful when we talk about heights. What are we talking about? The height here. So in this case, the height from the top of the pyramid to the base of the pyramid in a straight down, so making a right degree angle right down to the middle, right angle, the height from my finger to my thumb is called the vertical height. Okay? So I'll do that one over here in this drawing. So we go from here down to the middle. And I noticed that I stopped right in the middle and I put my right angle there. So that goes right to the middle of the base at a right angle. That height is called the vertical height. And that is not used for surface area, okay? So the easiest way for you to remember this is think about the location of each of those heights. Where is the location of the slant height? Well, the slant height is part of the exterior of the shape, right? It's on the outside of that. If I fold it like that, the slant height is part of the outside of this pyramid, and the outside of the pyramid is called the area or the surface area. And where is the height of the vertical height located? Well, the vertical height is located from the very middle of the vertex straight down to the inside of my pyramid. So the inside of my pyramid is where the vertical height is. And if we're calculating the things that are inside of a three-dimensional shape, that's not surface area, but instead that is volume. So we use the vertical height for volume, vertical height for volume, VV, vertical height for volume, vertical height for volume. And then we use the slant height for surface area, slant surface, slant height for surface area, vertical height for volume. Super important that kids get the difference between those two, because if not, if they use the wrong dimension for their equation, then they're going to obviously not get the right volume, or they're not going to get the right surface area, whichever one they're calculating. Okay, so the vertical height is in the middle of my shape. It's where the volume is, and the vertical height is used for volume. And the slant height is on the surface of my shape. It's on the edge of my shape, the surface of it. It's on the surface of it. And so we use the slant height for the surface area of my shape. Okay? Okay. So that's two of the three shapes I want to talk about. You can see dimensions, not a big deal, right? Pretty simple, straightforward. Rectangular prisms and prisms in general are much more straightforward. Pyramids are a little bit tricky because we have two different types of height. And then we have the third one. And the third one is a cylinder. All right, so now we're going to talk about the surface area of a cylinder. And so cylinders, we didn't talk about their nets the other day because I knew I was going to talk about it today during this whole lesson. So we're going to talk about what a cylinder might look like and what the net's going to look like. So I've prepared one over here. Again, this is something that you guys would have done in class had we had some time to do it in class. So here's my cylinder, and then I put a little piece of paper on the outside just so that you can tell the difference in color, right? So you see that I have a top there and a bottom there, and then around this side is my white part. Okay, so this is the side of the cylinder and this is the base. So if I'm gonna stand it up, I stand it like that. I wouldn't stand it like this, right? That doesn't seem to be standing up because it could be roll around or whatever. So that which we call standing up. All right. So okay. So the question is, if you were to unroll this, what's it going to look like, right? If you're going to take this apart, what is this surface area going to, or what is this net going to look like? Well, clearly I could take this top circle off, right? That would come off and that would come off. So I'm going to have a circle above and a circle below, right? So two circles, just like we had for the base of all of my other prisms. I had the base of the prism on top and had the base prism shape on the bottom. If it was a triangular prism, triangle on top, triangle on bottom, and then what was the shape that was in the middle? Well, they were all different rectangles, right? So I had the triangle base, and rectangles in the middle. And I would have 3 rectangles because the triangle has 3 sides. If I had an octagonal base, I'd have an octagon on top, an octagon on the bottom, and then 8 rectangular shapes through the middle. That's just the way the prisms are, okay? So this is not a polygon. So I'm gonna have a circle on top and a circle on the bottom. The question is, what's the shape gonna be in between there? Every other time we've done this, it's been a rectangle, but I'm curious if it's gonna be a rectangle this time, okay? So what I can do here is I just tape this on. So it'd be nice if I could take that white part off. So, okay, so here's my cylinder, and then if I unwound this, what shape does that seem to make? And it looks like it's making a rectangle. That's exactly right. It does make a rectangle. So even the cylinder, which we think of as very round and not having any straight edges, is also going to be the base shape on the top, the base shape up on the bottom, and then a rectangular shape in the middle. And that's what we're going to kind of talk about. This rectangular shape is kind of tricky to understand, okay? For kids, it's super hard. A lot of times what I do is have them bring in canned goods, peaches or whatever, and then they take the label off. And when they take the label off, I'm asking them to prick what shape is the label going to be. And almost always they say some sort of roundish shape. They're going to say some sort of circle or whatever. And when they take it off, they clearly can tell that it's not going to be a circle. It's actually a rectangle. The only kids that really know that it's a rectangle is if they have already taken them off for some reason. Okay, so there we go. So now let's talk about it. So I'm going to draw my net then. So I'm going to draw my net. I'll have my base, my 2 bases. Okay, so my bottom and my top. All right, so I've got a base here and I have a base here. All right, so now when I do that, so here we go. So here's my top. I've got it sitting like this. So if I were to fold that down and then fold this one out and unroll it, whoops, it would look like this. Okay, so that's what it's going to look like. So I'm going to have a circle on the top and circle on the bottom. Again, it doesn't really matter where you put them. So I like to put, for the cylinder, I like to put 1 circle on this side and 1 circle on the opposite side of it. And then in between there is the rectangle that we have. And it's touching both the top circle and the bottom circle. So then what I have in between is a rectangle. Okay, just something like that. So there's my shape. Okay, so that's my net. That's what the net would look like, is I would have a circle on top, circle on the bottom, and then a rectangle that connects both of those. So here's the question that I have is, where are these dimensions of this rectangle in this original shape, right? So where is the height of this rectangle? What's the base of the rectangle? Like, how do I figure out what these dimensions are when I'm looking at this? And that's kind of why I left this yellow gap in between here when I did this, because I want you to be able to see that the height between, or the distance between these 2 bases is the height of my rectangle. So I'm going to draw that in right now. Okay. So what I have here is I have my cylinder still, right? So I still have my cylinder, but then I've colored in the distance from one of my bases to the other. And now let's take a look at where that is when I unroll this. All right, so look at that. The distance between this red circle and this red circle is the distance between those two, which is that red height. And you look over here, it's the red height on that side. So I'm going to roll it up again and do it one more time so you can see it. Now that you kind of know what you're looking for. So there we go. So there is my height, or the distance between the bottom base and the top base. The bottom base and the top base. I just drew some red on there to show where that height is. So now when I unroll this, you can see that that height is the distance that's going from this base to this base. That's the distance between there. So it's the same as that height right there. And of course, on this side, it's the same as over there. Okay, so that's kind of cool. So now I'm gonna go ahead and adjust this a little bit to make those red. So the red height goes from the red circles, so the red base to the other red base, the top to the bottom, is the same as that red height right there, okay? So now the question is, if this red is the distance between these two, how far is this part? Like, how far is that? So I'm gonna go ahead and open it up. Okay, so there it is. That's my rectangle. And I'm gonna go ahead and color this rectangle because I wanna see the side that I'm talking about here. So I'm trying to find out what is the distance. How far is this from here to here? Okay. And then also the distance from here to here. It's going to be the same, of course, because it's making a rectangle, but I like to just kind of color on both. Okay, so there we go. So that's what I'm trying to figure. I already know that the red is going to be the distance between the two bases. What I don't know is what's that green? So now I'm going to roll this back up so I can look at the shape again when it's a three-dimensional shape. And what would you call the green part of this? Well, looks like the green, which is right here, right? So let me see here. Where's that at? Right there. So what do we call that part of a circle? That part of a circle is called the circumference of the circle. So the length of this green line is equivalent to the circumference of that circle. So if I could find the circumference of that circle, then I can find the length of that green line. So that means from here to here, this green part that I was just drawing on is the circumference of this red circle. All right? Okay, so this is the height between these two bases, right? So the H is the height, and the green is the circumference of that circle. When I unroll this, that green part is equal to where the circumference of that circle is. It's the same distance because I roll it around, and sure enough, that green goes all the way around the circle. So if I can find the circumference of this circle, I know the dimensions of this rectangle. Okay? Okay, so you see that the prism is the easiest one. The triangular the pyramid's a little bit tricky, and of course the surface area of a cylinder is very tricky. All right, let's take a look at a couple of problems now. All right? So, first one here is we're going to find, let me zoom out. We're going to find the surface area of a rectangle that has the dimensions of 3 by 5 by 10. Okay, so a 3 by 5 by 10 rectangle. So the first thing I'm going to do is I'm going to draw my rectangle in here, and I'm going to draw it like this time. So I'm going to draw the front piece and the back piece. Okay, because I always know I have a front and a back, right? Can't talk. Okay, so there we go, front and back. And then I know that I have a bottom, which is right here. And it's back here as well. And then I got this part here, and then it's right there. So I have a bottom piece, but I'm not going to draw the top piece on. I'm going to leave the top piece off for a second. And then I also have the left-hand side piece. So I've got this one right here. And now when I draw it like this, it looks like maybe the box is open. So it's got a backside, a bottom piece, and then this left-hand green piece. So what I've done basically is I've colored these ones. That's the red, and that's the red. Okay? So that's that. The red is the front and the back pieces. And then I made this blue piece down here. The bottom is blue. So if I'm holding it like this would be blue down here. And then the piece back here, that green piece right there would be over here. So if I'm holding it like this, red and red, the bottom piece is blue, and that green piece right there would be on this back side. So I have three pieces, excuse me, that's not true. I have two pieces that are not colored. I have the top piece that's not colored and this right-hand side piece. That way you can look inside the box. But I know that this right-hand side piece is going to be the same as that green one. And now the blue piece is going to be the same as the blue base. I just didn't draw them on there because I wanted to be able to look inside this box. Okay? Okay, that helps kids kind of visualize what we're doing. So it looks like I'm going to have two reds. Right? So if I could find the area of one red, I'm good. Then it looks like I'm going to have two blues, even though I don't have two blues drawn. I know that I have a bottom base and a top base. And then I'm also going to have two greens. So I have two blues, two reds, and two greens. Okay, so now I can draw my net for this. Okay, so if I draw the net, I'm going to go ahead and put the blue one as my base here, because that's kind of where it's sitting. You know, it's, let's see, I'm going to draw like this. So actually, you know what I need to do is I'm gonna go ahead and put my dimensions in first. So I'm gonna have 3 is right here, all right? And then I've got, maybe I'll do these in black, not colored, because I'm not gonna be color coded. Okay, so the 3 is my shortest side. The 5 is my next shortest side. And then this blue one here to me looks like the longest side, all right? Okay, so now when I go to draw my net, I have my blue side like this, are two very long ones, and then that is connected to two reds. So that's like this. Okay, so then I'm gonna go ahead and draw the rest of my red there. All right, and remember, so we got top base, bottom base, and then rectangles in the middle. And it could be front and back. The way I'm drawing mine, it's actually front and back. So front and back. It doesn't really matter, but you're going to have two that are outside and then a row of rectangles. So now it looks like that this green one here would be right over here. Okay, like that. That's the green one. And then on this side, it's missing a green one. Okay, so that's one's not there. And then the very last one would be another blue one. Whoops. All right, so there's the blue one. That's a terrible looking blue one. It's not even close to their side. Okay, so there we go. So now I've got the front and the back are my red ones. The left side and the missing front side are my two green ones. And the bottom base and the missing top base are my two blue ones. So now I can put in my dimensions. Well, I see that the blue is 10, right? So that's 10. Okay. And then I see that the smallest height, the 5, is right here. So that's a 5 right there. From here to here is 5. Sorry, no, it's not. The smallest one I have is 3, not 5. The smallest height is 3, okay? And then the other side of the base there is 5. So that's 5, okay? So I got my dimensions out. I got my 10 is on the side there. So that means all of these distances across the board here are all 10 because that makes this a rectangle. So that means that this is 10, this is 10, this is 10, this is 10. They're all 10 going across there. And this side over here must be 3. Right? Because that side's 3, that side's 3. And since these are the same shapes, then this is 3 and this is 3. All right? So then I have this is 5, so that must be 5 right there. Okay, those are all 5. And the question I have is, what is this right here? What's that distance? And what's this distance? These are the questions that students may not know. This is 10, but how far is this? Well, that blue one has to be the same as this blue one. And that blue one has that distance of 5. That means this right here also has to be 5. So from there to there is 5. I'll clean that up a little bit. Okay, so that part right there is 5. And then the question here is, what's that one? And that's a tricky one. But the way I write this, it kind of makes it look nice because that 3 can count for this red side and the green side. So both of these sides are 3. Both of those sides are 3, not just the red side, but also the green side. So these two sides are both 3. So that green dimension is going to be 3 right there and then 10. So then you can do your formulas, right? So for my blue shape, blue, I'm gonna do it like this. So the area of the blue is equal to base times height. And my base is 5 and my height is 10. So the total area is 50. And then I have 2 of those. So I multiply by 2. So I get an surface area of 100 for my blue shapes. Then I'm gonna do the area of my red. Okay, so area of the red, it's not AR, it's area of the red. That's also base times height. But this time my base is 5 and my height's 3. So that gives me 15. And then again, I have 2 of them. So I multiply by 2 and I get a total of 30. And then my last one is that green one there. Let me use a darker green so it shows up. So the area of the green is equal to base times height. And this time my base is 3. From there to there is 3. And my height is 10. So that gives me a total of 30. And then I have 2 of them. So that means 60. So then my total area is going to be all of these added together. 100 plus 30 plus 60, which gives me a total of 190. If I didn't need the room down here, I would have just added it going down. Actually, I guess I could have. I didn't realize that was the same problem. So 190 is the surface area of that shape right there. Okay? So you can see when you open it up, it's easier for kids to see that I have 2 of the same shape, 2 of the same shape, 2 of the same shape. And they're always separated, like it alternates, green, blue, red, blue, red, right? It's always the way it's going to be. They're going to never be right next to each other. Okay, so that's the rectangular prism. Now let's take a look at the rectangular pyramid. I said prism, it should be pyramid. Sorry. We just did the prism. Okay, so the rectangular pyramid. And it says I have a